Hello and welcome back to Science, Mr. Robertson, and today it's going to be my favourite things, talking about the universe. How the universe started and how it ended. We know we're able to work out our universe is the equivalent of about 400 million years old. Sorry, that's wrong. 400 billion year old. 400 billion years old. A very, very, very long time. But how did the universe begin? We don't know. What we do know is this. What a time that we're going to call 0 seconds. Everything we know about was in a space that big. Infinitesimally small. The tiniest, smallest space ever. Everything we know was in that space. And for some reason, that space went from nothing into everything. We call that the start of our universe. It's called the Big Bang. And basically what happened was everything we ever knew about suddenly existed. Suddenly our universe got bigger and bigger and bigger and bigger, and it's continuing to this day getting bigger. All the stars, the planets and the galaxies have came from this expansion. However, if I go into space, most of space now is quite empty. At the start, everything in here, there's lots of things going on. It is a crazy, crazy thing. Now, it is, I don't know how many million times more big it is, but it's big. And basically, everything is really spread out. At the start, everything in one place, and it's been getting bigger and bigger and more spread out. In between things in space, so if I have, 2 planets here, for example, I've got all this empty space. And that is what it is. It is just that. Empty space. There is no solid. There is no liquid. There is no gas. There is nothing there. A place with no particles is something that we call a vacuum. Vacuum is a place with no particles in it. And we use that, like we have vacuum cleaners to make our floor clean. And dammsuger på svenska. What that vacuum cleaner's gonna do is take all the air out, so there's nothing in it, so more air comes in, and it's dirty. So it cleans the floor. Very clever. What we have now is all this empty space and a universe that is constantly getting bigger. A question people always ask is, what is it getting bigger into? And it's not getting bigger into anything. It's just getting bigger. That doesn't change. So it just gets bigger into nothing. Because everything we know about is in here, is in our universe. And as I said, our universe is getting bigger. If I had a little graph on here, And I had, on here, I had size of universe. And I had time on the bottom. Now I know at time equals 0, the size of the universe is 0. It started from nothing. And then from there, it has got bigger and bigger and bigger. Now there's 3 possible ideas I could have for how it ends. One is the universe keeps on going, and keeps on going. It gets really big. It gets so big. It never stops getting bigger. That is one idea. I call this the open universe. It just continues getting more and more open. What I could have is an idea like this, where it's going up, and then maybe it gets to here. And it starts to stay at the same size. This I call flat. The universe hits a perfect size, like you're blowing into a ball. It has the biggest size it can, and it just stops. The alternative would be a universe like this, that got to a biggest point it could, and then came down and down and down. Eventually getting to a point where it crashed, and the universe went back to the beginning, all in one space. This is called a closed universe. The universe starts to close on itself. At the moment, we know that the universe is, well, our time here, 14 million years. It's about here. Our line is so perfect, it could be either of these. I'm just making that a bit straighter for you. There you are. It could be either of these here. We don't know which one it is. At the moment, our science is telling us that we think our universe is the open type. All that empty space we have in our universe, well, we think in the vacuums, they may have something I'm just going to call dark energy. And I'm not going to explain that at year 9 level, never mind year 6. But we think, basically, there is some energy, we don't know what it is, that is therefore be said dark. And that dark energy is pushing our universe faster and faster away from each other. It sounds good. The universe is not going to die. It's going to get really, really, really big. That is true. It will keep getting bigger. But I can't make anything more. Everything's going to get bigger and bigger. And there'll be more empty space. So in my open universe, if this is true, it'll be open, it'll be empty. And för att allting har sprids ut och det också inkluderar energi, it's going to be really, really cold. The whole universe is going to spread out and become even colder with less and less atoms and less energy in every single space. And seriously, our universe is already very, very big. We have a measurement to describe how big it is. And it's crazy because our measurement is what we call a light year. Light is the fastest thing we know in the universe. Light travels at 300 million meters every second. That is crazy fast. It takes 8 minutes which is 480 seconds for light from the sun to get to Earth. The sun is 8 light minutes away. The next closest star isn't 8 minutes away. It's 4 light years away. Think about that. The closest star to us. And look, think how many billions of stars you can see in the night sky. If I'm here on Earth and I'm looking at this other star, it takes 4 whole years for the light to come. 4 years. So if I'm here on Earth and it's 2016, I am looking at what this planet was in 2012. It takes 4 years for the light to move. Imagine how slow it would take humans. Yes, our universe is crazy and full of exploring, but it's way, way too big to go and explore. Thank you.